In the last lecture, we have seen colloids. Now we are going to study what is ion, that is ion exchange, then cation exchange, then anion exchange, cation exchange capacity, and anion exchange capacity. So let's start. What do you mean by ion? As soils are formed during weathering processes, minerals and organic matters are broken down to extremely very small particles. Then further, these particles cannot be seen with the naked eye. They are very smallest, called as a colloids. Colloids have size less than clay particle. Clay particle has a size of point less than point not 2 millimeter in diameter, but colloids have a size less than point not 1 millimeter in diameter. Many colloids are plate-like structure and crystalline, depends upon kind of parent material. Each colloid has a negative electrical charge due to formation processes, which can attract positively charged particles as poles of magnet which attracts each other. Then what I mean by ion? Ion is an element with an electrical charge is called as ion. An element, any element with electrical charge is called ion. Whether it is positively charged, then it is called as a cation. If it is negatively charged, it is called as an anion. So ions with positive charge are called as a cations. Example of cations are potassium, that is K plus, sodium Na plus, hydrogen H plus, calcium Ca plus, and magnesium Mg plus plus. Then what is an anion? An ion with negative charge are called as anions. Examples of anions are chloride, that is Cl minus, nitrates NO3 minus, sulfates SO4 minus minus 2 minus, then phosphate H2PO4 minus. These are called as anion. Negatively charged colloids attracts cations and hold them like a magnet holding with small pieces of metal. These characteristics explain why nitrogen is more easily leached from the soil than ammonium nitrate. It has negative charge like soil colloids, so it is not held by the soil but remains as a free ions in the soil water and to be leached through the soil profile. Then cation. Cation held by soil can be replaced by other cations. That is, cations with dominant electrical charge or that is having more cation exchange. The total number of exchangeable cations a soil can hold is the amount of its negative charge is called as a cation exchange capacity. In other words, cation exchange capacity is sum total of exchangeable cation that a soil can adsorb is called as a CEC or cation exchange capacity. What is the significance of CEC in agriculture? Higher soil CEC, the more cations it can retain. The exchangeable K is major source of plant K. Then exchangeable magnesium is often a major source of plant Mg. The amount of lime required to raise the pH of acidic soil is greater than CEC if the CEC is greater. Cation exchange sites holds Ca++, Mg++, K+, Na+, and NH+. Then cation exchange sites hold fertilizer K+ and Na+, greatly reduce their mobility in soil. These are some significance of cation exchange capacity in soil. The unit of CAC is milli equivalent for 100 gram. milli equivalent per 100 gram of soil. Then clay minerals are usually from 10 to 150 milli equivalent per 100 gram. That is, having organic matter, clay soils can retain large amounts of cations against potential loss by leaching. Percent base saturation. The percent of total CC occupied by the major cations has been used to develop fertilizer programs. The idea is to the idea is that certain nutrient ratios or balances are needed to ensure proper uptake by the crop for optimum yields. Some researchers has shown that cation saturation ranges and ratios have little or no utility in the vast majority of agricultural soils. Under field conditions, ranges of nutrients vary widely with no detrimental effects as long as individual nutrients are present in sufficient levels. Then, what are cations and their symbol and their ionic forms? Okay, some common soil cations and their chemical symbols and ionic forms are potassium, that is, chemical symbol is K and ionic form is K plus. Sodium, having chemical symbol Na and having ionic form Na plus. Hydrogen, having chemical symbol H and ionic form as a H plus. Calcium is a having chemical symbol Ca and ionic form Ca plus plus or Ca2 plus. Magnesium, having chemical symbol Mg and ionic form as a Mg plus plus or Mg2 plus. Then there are some anions with chemical symbols. Their ionic forms are chloride or chlorine, having chemical symbol Cl and ionic form Cl minus. Then nitrate, having chemical symbol N and ionic form NO3 minus. Then sulfate, having chemical symbol S and ionic form SO4 minus minus. Phosphate, having chemical symbol P and ionic form H2PO4 minus or PO4 minus 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 3 minus. Then due to like poles, charges repel each other, and unlike poles, that is positive and negative, which attracts each other, that is called as a, when like poles are present, it is called as a like poles charges. When having similar charge, they repel each other, and unlike poles, that positive negative which attract each other. That is a pictorial example of attraction of cations on colloidal surfaces, that is soil colloids. Then we have already seen cation exchange capacity, that is, cations are positively charged nutrient ions and molecules. We have given some examples like calcium, magnesium, potassium, sodium. They can attract each other. Then there are certain clay and organic matter particles. Clay particle has a negative electrical charge which attracts positively charged ions on surfaces of clay particles. Okay, soil depth and soil particles, soil productivity we have to see later.